that was what we have discussed till now. That is, what is the instantaneous frequency in the case of frequency modulation? We are comparing this instantaneous frequency of frequency modulation with the instantaneous frequency in the case of PM. Right? So we have to what we have to do, we have to differentiate it. That is, we know that what is formula for omega I, which we discussed earlier. That's omega is equal to integration of psi dt, right? So we'll have to write the expression for this psi I. That is, psi I is what? Integration of omega ct plus omega ct, not integration, sorry. Psi is equal to what? Psi I is equal to, you know that we have discussed the psi I, which is equal to omega ct, right, plus kp ft. This is the value of phase angle in the case of PM. So if you want the value of omega I, so what we have to do, we have to differentiate it. That is omega equal to d sine upon dt. So now we get the value of this omega I in case of PM, that is frequency, in the case of phase modulation. So omega I comes out to be omega c plus kp d upon dt of, right, wait, kp into d upon dt of ft, right? So this is your equation number 10. Now you can clearly see that is the instantaneous frequency in the case of frequency modulation varies linearly with the ft, but in the case of PM, this is the instantaneous frequency for what? FM, for FM, and this is for PM. Now you can clearly see that this is for FM, this is for PM. You can clearly see that. Thus, in the case of FM, this instantaneous frequency varies linearly with the ft, but in the case of PM, that is in the case of phase modulation, this instantaneous frequency varies with the time varying derivative of ft. This is the difference, right, between the instantaneous frequency of the instantaneous frequency of the frequency modulation and the instantaneous frequency of the phase modulation, right? Now let's move ahead. That is, now if you have to find the value of if you want to calculate the total phase angle, so how we can calculate it? First of all, we have to write, that is, we have to find the value of psi I. So if you want to get the total phase angle for this frequency modulation, how will we get it? We will get it like this. We get it like this. That is, first of all, so what we are doing? We are finding the total phase angle for FM. Total phase angle for, so how we can get it? We have to find the value of psi, and the psi is equal to nothing but this is equal to integration of omega I dt. So you know the value of omega dt. It is equal to omega c plus k f ft. This is your equation number. Let's say this is equation number 11. This is equation number 11, right? And so the psi I, it comes out to be what? This psi I, it comes out to be what? It comes out to be omega ct plus kf, right? Integration of ft and dt, right? So the psi comes out to be kf integration of ft dt. So if you want to express this frequency modulated wave, so we have to write the expression like this. That is I f dt. It comes out to be what? A cos psi. So let's put the value of psi here. So now we can write it in that way. That is equal to A cos, and this is equal to omega ct integration ft dA. So this is equation number 13. Now suppose if we consider that this phase angle, the phase angle is 0 at t equal to 0. Okay. If we consider this phase angle is, if we consider that the phase angle is 0 at t equal to 0, so this will limit limit of integration will go from 0 to t. So now this equation can be rewritten as, which I am writing it here, that this equation can be written as I f n t will be equal to so what I am doing, I am rewriting this equation by, if what I am considering, I am considering that the phase angle is 0 on assuming, what we are assuming, that phase angle is 0 at t equal to 0. So what we will get? We will get phi f m t is equal to a cos omega ct plus k right, integration over 0 to t ft dt. So that's how we can express and frequency modulated Kaggle wave. Right? This is equation number 4. This is the last equation for that. So now we have understood what is the frequency modulation, what is the phase modulation. Now let's move on to our next point, that is what is the relation between FM and PM. Now what is the relation between FM and PM? So let us discuss the relationship between PM and FM. Relationship between PM and FM. Relation between PM and FM. Now, you know, if you have to relate this phase modulation with the frequency modulation, so we can relate it. Why so? Because the objective is same, the purpose is same. In both the cases, we are making the changes in the total phase angle. Sorry, as you have seen, if we see the phase angle varies linearly with the ft in the case of phase modulation, but in the frequency modulation, it varies with the integral of ft. So if you want to generate the frequency, if you want to generate FM using phase modulator, we can do it. So first of all, we have to do what we have to do. First of all, we have to pass the signal ft from the integrator. Then we will pass it through the phase modulator. How we will do it? That is, so first of all, we have, if you have a signal ft, so first of all, this signal will be passed through integrate. We have to pass this signal. The signal ft will pass through integrator. So first of all, this signal will pass through the integrator. Then after that, it will go to the, where it will go? It will go towards the phase modulator. It will go to the towards the phase modulator, right? Now here, so what you will get here? You will get the integration of ft dt. Here. This here, from here, this signal will go towards the phase modulator, and here the carrier generator will be there. A carrier generator will be there, which will generate the signal a cos and which will go to the phase modulator, and here we will get the phase So this is what? This is the FM generation using phase modulator. So this is the relation between that's how we can generate the FM signal using phase modulator. So as you know, in the case of phase modulation, the phase angle varies linearly with the FT, but in the case of frequency modulation, the phase angle varies with the integral of FT. That's why if you want to generate FM signal using phase modulator, what we'll have to do? First of all, you have to take the signal FT. Then we'll have to let it pass through integrator. Then it will pass through the phase modulator, and in this phase modulator, two signals are coming. One is from integrator, one is from carrier generator, E cos omega CT, and at last we will get the value of FM. So that's how we can generate the FM signal using phase modulator, right? So now let's move on to the next part, that is how we can generate the PM signal using frequency modulation. Now you know, as in the case of frequency modulation, the phase angle was varying with the integral of FT. So similarly, in the case of phase modulation, you know that in the case of phase modulation, what happens? In the case of phase modulation, this instantaneous frequency varies with the time derivative of FT, or with the differentiation of FT. For that purpose, what we have to do? We have to change the approach. That is, now we are going to discuss that how we can generate the PM signal by using frequency modulator. So you know that is, in the case of FM, the instantaneous frequency varies with the time derivative of FT. So what I will do? I will do it like this. That is, I will be having a signal FT. It will pass through the which block? It will pass through the differentiator. It will pass through the differentiator. Then it will pass through the frequency modulator. And here I'll be having another block. Similarly, there will be having the carrier generator. Right? So here we will get the PM. This is the phase modulator. So that's how we can generate the phase modulated signal using frequency modulator. So what we have to do? First of all, we have to take the signal FT. It will pass through the differentiator, right? So we will get the signal which is the differentiated signal rather. Okay, and it will pass through the frequency modulator, and it will get multiplied with the carrier generator, which will this carrier generator will generate a signal A cos omega. This is the signal which is A cos omega. So this is the PM generation using frequency. So that's how we can establish a relation between the PM and FM. So that's it for, I guess, today. So far we have discussed what we have discussed. That is, we have discussed what is the angle modulation, and what we do in the angle modulation, what is the instantaneous frequency, how many types of modulation which are there, and what is the relation between these two modulation, right? So that's it for today. See you again. Thank you very much.